I'm Michelle Carre.
Oh my God!
This is the kind of chaos that is carefully calculated.
This is what it takes to build a Nissan.
A lot of people see a vehicle after it's been crashed and they say, oh, look at the front end, it's destroyed. I can't believe people survived that. But that's all part of the plan. The scope of our work here in this building is full vehicle level crash testing, pedestrian protection for the outside of the vehicle, as well as protection for the occupants inside the vehicle.
Crash testing is so important because the end goal is to keep our customers safe. Here it's dummies and data and sensors, but in the real world, it's real people being able to walk away from a crash.
This looks pretty serious.
It does, but this is all intentional. This is all meant to happen. The goal is to absorb the most amount of energy that we can in the front of the vehicle so that that energy is not translated to the occupants.
The crash was insane to witness in person. This is a good result.
It's part of our criteria to measure how everything deformed. Did it move the way that we planned it to? Did the metal crumple? Did parts break the way we intended to and the way that it was all planned out? We'll 3D scan and measure every part, compare it to past results, compare it to the computer simulation that we've done in the past. We're going to great lengths to figure out all these details, plan it out, and finally confirm everything worked as intended. And it all culminates in a vehicle that we feel proud of and our customers know that they're safe in.
That is some serious engineering.
Thousands of hours that go into all the detail of every single part that has to do its job in just 300 milliseconds.
Tomorrow, that could be a real dad driving his kid to soccer practice in a head-on collision. And so knowing that the decisions that we're making here today are going to affect someone out in the real world, that's fulfilling for me.
Elizabeth, where are we headed next?
You just saw the dummies in live action crash. Now we're headed over to the ATD lab where you'll see where we calibrate and instrument these dummies pre and post test to get them ready.
So what does ATD stand for?
Anthropomorphic test device.
Meaning human-like.
Correct. These dummies are so biofidelic, they replicate how a human body would react in an actual crash test. This is where all the ATD magic happens.
We are in the dummy and instrumentation lab. It's where we house all of our dummies. It's where we test them, we dress them, we get them ready to go when it's their turn in the crash lane. Kind of what's inside, you can see here's the pressure sensors. It's just kind of a little bags of pressure. If you look down inside the ribs, there's all the instrumentation, different points that we're measuring, head acceleration, neck load, chest deflection.
So it's a super high data input device.
This one is over 150 channels.
In the prior crash tests I've seen before, to the naked human eye, it's like a mannequin. This is a $1 million mannequin.
Right. And it'll move just like a human. I mean, you can see the way this one moves. It's got the shoulder joints that are advanced. Instead of just measuring data at specific points, this one actually moves closer to a human body. So that gives a lot more opportunity for getting multiple points of data. We use all of that data together to make a big picture of what's happening.
At the end of the day, this is about saving lives.
Exactly.
So next we are going over to the pedestrian lab, which is still very much safety, but now we're talking about the people outside the vehicle.
So this is a static test lab. We can influence the design in ways that allow the pedestrian to walk away from the crash with minimal injury. What we're getting set up to do here on this Pathfinder is to run a lower leg impact test. The leg form itself has a bunch of sensors, replicates lower leg of a human. We put it on this fixture here and launch it at the front bumper structure of the vehicle at about 25 miles an hour.
What is this supposed to simulate in a real life situation?
The dummy is launched as if pedestrians being hit kind of broadside, side on the knee. And that's the most common collision scenario between a vehicle and a pedestrian, if you can imagine. After the test, download the data from the leg, check what breaks, what doesn't break, analyze the data to see what level of injury was sustained.
Oh my God. That was like a body exploding at the car. So we can look at the data afterwards to determine the impact to the pedestrian.
We can assess what level of injury would be sustained.
What is the impact to the car?
That's the other piece of the puzzle. There's specially designed energy absorbing structures in the front bumper, and the goal is to control the way that the leg intrudes into the bumper structure. At the bottom, the center, and the top, we do a lot of development before we actually launching impactors, collecting injury data, making sure there's ways we can mitigate risk for the pedestrian.
Where does this test fall in the overall broad spectrum of testing at Nissan?
We're just one corner of even just this single lab. Even just within safety testing, when you're designing these vehicles, they go through a series of tests, and we're just a piece of that puzzle. A lot goes into checking these designs that are being developed and making sure that they're safe to put out there on the road.
Conducting these tests here and being able to control the environment and put these vehicles through the worst in this building maybe means that someone doesn't have to go through that out in the real world.
The work that y'all are doing here is going to help so many people be able to walk away from these unexpected events. And it's really, really amazing to see all of the hard work and attention to detail you and your teams are putting in for this. Thank you so much for having me today, Elizabeth. This was such a cool day. I can't believe everything we saw.
I'm so glad we could show you a little bit of what we do here. Come back anytime.
Yeah.